Welcome to problem of the day number 23. Find the forces in the system. So this is an equilibrium problem. We're trying to solve F1 and F2, and you have your quadrants, so positive, positive, negative, positive, negative, negative, and then positive, negative quadrant. So quadrant 1, 2, 3, and 4, and that's indicative of what's going to be negative and positive per the vectors. Like this is in the negative y, and then nothing in the x, and then this is in the negative x but positive y, and then this is both positive. So when you write the equations, you have to sum forces in the x and sum forces in the y. So we'll sum forces in the x first, but I wrote out the triangle. So the opposite is going to be sine, opposite is going to be sine. So both the y components here are going to be using sine, and then both the x components are going to be using cosine. So sum the forces in the x, we're going to have F1 cosine 30, since that's in the positive direction, it's positive, minus F2 cosine 45 in the negative direction. So then I changed it into a decimal point and then solve for F2. And then this is the equation for F2. And then I take the sum of the forces in the y, so sum force in the y equals 0, and then you got negative 150 because I said upward y direction is positive, plus F2 sine, like I said before, 45 degrees, plus F1 sine 30 degrees, F2 sine 45, plus F1 sine 30, and they're both in the positive direction in the y. And now I start solving for and substituting in F1. So 150 equals F2 0.707 plus F1 0.5, and then this is where I sub it in, and here's a better summary of what I'm subbing in, right? This is, I simplified it down and then subbing this in, and I get 150 equals F1 1.36 3, and then I get F1 equals 110, and then I can solve for F2 because I have F1 already solved for, and plug in 110 times 1.22, and that equals 134 pounds. So 110 pounds and 134 pounds for the two forces respectively.